Hi, welcome to Computational Thinking, a Synopsis. You can find me on Twitter or check out my website or leave a comment. I would like to hear your feedback, so let's begin. What is computational thinking? Computational thinking is a critical thinking technique for people to come up with innovative solutions. It's like training the human brain to work and produce like a CPU. Simply put, computational thinking is broken down into 4 principles. Algorithms, which is a series of steps to attain a goal. Pattern recognition is when we find trends and similarities. Decomposition is the breaking apart of a bigger problem into smaller, manageable pieces. And abstraction, which is removing details but applying general principles. We use these strategies all of the time, but just may not have known it or known that it actually has a name and that it could be very productive and almost necessary to the 21st century learner. Students of all ages can learn and apply these skills to the classroom and in life. They may even find these strategies fun and familiar. Why should we use computational thinking? Technology has expanded virtually every sector at an alarming pace. More and more people are needed to solve problems in their field with skills that were not taught in schools 20 years ago. CT brings the power of the human brain and the digital age together in order to solve problems either globally or in your backyard. Who can use it? Computational thinking is for everyone. Watch my 4-year-old daughter and I use CT critical thinking skills in a playground. How can CT be used on the elementary level? I have examples of computational thinking within 4 subjects. I'm going to use offline and untechnical examples because it's too easy to demonstrate how computational thinking can be used in computer science or with an actual CPU. The whole point is to strengthen the brain to compute, not just retrieve the output. I'm going to focus on the upper elementary levels because I think these topics can be easily modified for upper and lower grades. I'm going to show you how it could be used in subjects that are not as obvious. Let's start with reading. Analyzing a story with a plot diagram breaks the story into smaller pieces in order to better illustrate the climax. The plot diagram decomposes the story into an algorithm, so to speak. Each is labeled according to the function in the story: exposition, rising action, climax, falling action, and conclusion. These steps can be used to analyze different fiction or nonfiction stories, poems, or prose, as we see with abstraction. If we look at many stories within the same genre, say mythology, students can use a plot diagram to identify patterns or similarities within the stories and make conclusions about mythology and its origins. Then maybe make their own mythology story. Moving on to writing. When writing a personal narrative, the essay can be broken down into smaller narrative techniques: plot structure, characters, points of view, settings, and themes. Brainstorming ideas within these techniques can build the foundations to the final product. When adding dialogue, students may have many characters speaking with different sentence types. To solve the problem on how to use dialogue punctuation correctly with different sentence types, students would utilize abstraction for the dialogue punctuation structure. Let's look at 2 examples. Olive said, quote, "I believe she will do a great job at the race, period," end quote. Lucas asked, quote, "When will the race start? Question mark," close quote. We see here 2 different types of sentences, yet a similar structure to the punctuations for the dialogue. Moving on to math. A favorite recipe is a great example of CT in math. Let's look at the recipe for animal toast. We see algorithms in the amount of ingredients and decomposition in the broken down set of sequenced instructions, or even when turning the recipe into a fraction lesson. Abstraction is when we start the toast with a base set of instructions. For example, for all toasts, number 1, toast the bread in the toaster for 60 seconds. Number 2, let it cool for another 60 seconds. Number 3, spread 1 tablespoon of a spread like cream cheese, peanut butter, or Nutella. Then we can add our own personal details in step 4. You can use strawberries, bananas, and blueberries to create a chosen animal face. Here, students can take the foundation and then apply it to their own desired animal face. Kids would love using a fruit pattern to illustrate the animal's markings, like a tiger's stripes or a peacock's feathers. Food in the classroom is always a fun and innovative tool. Moving on to social studies. Analyzing battle plans with maps is computational. Look at the Battle of Trenton. Here on the map we see General Washington's troops starting together in the wee hours of the morning of December 26, 1776, crossing the Delaware River and then splitting into two. One band going into Trenton on the west and another band attacking from the east. Students can dissect the sequence of events of the plan in order to achieve a whole goal of the battle and create a timeline to visualize these steps. Students can take General Washington's strategy and apply to other environments or other battles. Would this plan be successful at the Battle of Monmouth? In conclusion, computational thinking can be used at any age or grade level with any subject. Once you understand these critical thinking strategies, you'll find them in all areas of your day. Feel free to comment or reach out over Twitter. Thanks so much for watching.